warahmatullahi wabarakatuh and good afternoon. Today we are going to present materials development for newly developed hybrid space rocket, and we are from Group A. My name is Nurin Izzati binti Suhameri. My matric number is 211915.
My name is Alexandrina Solana Augusta. My matrix number is 210318.
My name is Ain Nadhirah binti Mat Arif. My matrix number is 209938.
Okay, so our main prototype for this project is rocket. We create this prototype based on the most famous aerospace company base, which is NASA. As you can see, there's 4 fins here and a shaft, and also the shaft is based on the aerodynamic shape, and also there's a clip delta design, which is this clip delta design that produce low drag for the rocket to be sent to the upside. And then for the improvised one, we lessen the amounts of fins from 4 fins to 3 fins because we want to create more pressure so that the drag will be low, so it will be easier and lighter than usual. And also the shaft remain the same, which is the aerodynamic shaft, and also the clip delta design also remain. Next. Okay, so as you can see, this is the prototype's structure. There is a payload system and also guidance system at the upside one. And for this whole structure, we call it structure system, which consists the frame, the fin, and also the nose cone. And then we have propulsion system, which have fuel, oxidizer, pumps, and also nozzles. And there are 4 major systems from what I have explained just now, which is the structural system, the payload system, the guidance system, and also the propulsion systems. And the major parts of a rocket are the structural system, which is from the nose cone until the fin. Okay. For the rocket's material, we decided to choose for the nose cone, which is titanium composites that will be explained later. And for the frame, we decided to choose aluminium or titanium composite. And also for the fin, it is advisable, and we decided to choose carbon fiber. Next.
So now I'm going to talk about reason to use the chosen materials. So as we can see, there are 3 types of material that we're going to choose, which is titanium alloy, aluminium, and also carbon fiber. So each properties of the material is first titanium alloy. It have a very high specific strength. It also have a good high temperature mechanical properties, excellent corrosion resistance. For aluminium, it has low density. It is also non-toxic, have high thermal conductivity, also have an excellent corrosion resistance. Aluminium also can be easily cast, machined, and formed. It is also non-magnetic and non-sparking. It is the second most malleable metal and the 6th most ductile. For the carbon fiber generally have an excellent tensile properties, low densities, high thermal, and chemical stabilities in the absence of oxidizing agents, good thermal and electrical conductivities, and excellent creep resistance. Next. So as we know, like Nurin said earlier, there are 3 main frame for the rockets, which is nose cone, airframe body, and fin. For the nose cones, we use the metal that combine titanium and synthetic materials, which is known as titanium composite. It is a flexible and durable. Why we choose the titanium composite is because it is also lightweight and have amazing corrosion resistance. It also can survive a hot temperature. For the airframe body, for the main frame, mostly we use the grade aluminium or titanium, since both metals are very strong but lightweight. For the fin, there are 2 materials, which is the titanium leading edge, and then the second one we coat it with the carbon fiber. And then for carbon fiber, we're going to choose between 2 types of materials, which is epoxy or polyimide. So between those 2, both of it can survive a high temperature, but For polyimide, it costs a lot more than epoxy, so epoxy is chosen to be the layers that cover the leading edge. And also titanium leading edge is recommended for a strong fit. Next.
Okay, so for the discussion, the purpose of change and development is that we basically chose composite materials for the materials of the aircraft because they have lightweight properties. They have lightweight properties and can minimize the rocket's drag coefficient. This will then improve the fuel consumption and can also reduce the maintenance costs. On top of that, it can also increase the rocket's lifespan because it's more durable, and it's also resilient to fatigue, heat, corrosion, creep, and also failure. So for the impacts on society, this gives society the ability to use technology for communication or entertainment purposes, like the use of cell phones or television. Society also gets to learn more about space with the innovation of rockets. Humans can also travel around the solar system, and with rockets, there's also the innovation of the GPS. So impacts on the environment. A hybrid rocket engine produces lightweight set particles. Therefore, we will have better air quality because the air pollution is reduced. And this will also slow down global warming, and there will be fewer harmful substances that are released into the atmosphere. Okay. So for the material availability and cost, titanium alloy is used for this, and since it's used in a lot of aspects like biomedical, orthopedic, and chemical industries, they are automatically abundant. But however, they are expensive. But this can be solved by combining them with ordinary steels. As for aluminium, they are used for the fuselages, wings, and supporting structures. They are also abundant and inexpensive, and also easy to obtain. They are commonly used in military and modern aircrafts. And lastly, for carbon fiber, they are highly demanded for aircraft applications because they are lightweight, strong, malleable, however they are more expensive. Okay.
Yes. So far, that's all of us. Thank you.
Thank you.